All right, well, I'm Justin, developer and community organizer in the Seattle area. I work with Seattle JS and Seattle JS Hackers that bring you great events. I learned TypeScript in my last job as a front-end developer, working with a little ad tech startup, so I found it really fascinating, interesting. So this is mainly for people that are looking to get started, not really familiar with TypeScript, but familiar with JavaScript. So first, what is TypeScript? TypeScript is basically a superset of JavaScript, which means it adds a layer around JavaScript that adds more to the language, like adding the benefit of optional static typing. Normally, JavaScript is a loosely typed language. TypeScript can be a strongly typed language, and I'll get into why later. TypeScript gets compiled into JavaScript. So really, once you're done, it just all turns into JavaScript. TypeScript's mainly just for when you're building your web app or backend or whatever you want to build out of JavaScript. Most simply though, TypeScript is a open source language that extends JavaScript by adding data types. Even more simply, TypeScript is a JavaScript linter. Why would you use TypeScript? Well, a few reasons to use TypeScript are it adds type support to JavaScript, which is the main point of it. With typing, your code becomes almost self-documenting and easier to read, which you'll see why later too. Well, that is what we're going to go over today. It enhances IDE support, allowing you to find errors before compiling, and context tracking is transferred away from you to the IDE itself. First up is, what are types? Well, types or data types are a way to define our data and tell the compiler how we intend to use the data or what kind of data to expect. When you hear about type systems, you'll hear about dynamic and static typing along with strong and weak typing. Strong typing, you bind your variables to be a specific type and cannot change it after declaring so. With weak typing, you simply can declare a variable as one type and later change it to another. And static and dynamic typing is another concept in typing systems. The simple difference between the two is when you declare the type. With static typing, you must declare the variable type before you can use it. And for dynamic typing, when you use a variable, you are declaring its type or inferring it by the type of the data used. TypeScript can be a strongly typed language. I say it can be strongly typed because it has a way of turning off type checking and making itself weakly typed. How strong the typing is depends on how the user is declaring types. First up, we got basic types. If you're familiar with JavaScript, you're probably familiar with all these basic types: string, number, Boolean. Nothing too complicated here. More detail on strings. String can be either just a simple string or an interpolated string using variables. Except we have numbers, which covers, well, unlike some languages, TypeScript only has one type for numbers. Others might have a different type for integers and floats and such, but here you have numbers, a float, hexadecimal, binary, or octal numbers. I think Booleans are pretty self-explanatory. It's either true or false or a statement that will equal either. Before I get into more basic types, I want to go over the functions. Here we have a simple JavaScript function named add, and it takes an argument num1 and num2 and returns them added together. And here we have that same function in TypeScript. For the type, you can see the type indentations in 1 and 2. And then afterwards, you see the return type, which is why I wanted to go over functions before, because some of these other types that we'll see will only really be used for return types if used at all. And in most cases, the return type can be left out because it's inferred by what's being returned. More basic types that we're going to go over are arrays and tuples, objects and enums or enumerations, null and undefined, unknown and any, and never and void. First up, we have arrays. Just like JavaScript, TypeScript allows you to work with arrays of values. Arrays can be written in two ways. The first shown here is the type of the elements in the array, followed by an empty array or a pair of brackets to denote it is an array with only that type of element. Here we have the generic way of denoting arrays, but we'll get into more about generics later too. And next we have tuples, which is basically just declaring an array with a fixed number of elements that we know each type of each element. So you probably heard of tuples before, but this is how we type them in TypeScript. Objects. For objects, we can denote an object by using the type object keyword or using the object keys and their types inside of a braces. Generally, though, you will not use this way to denote your object because there's a much better way that we will go over shortly. Enums or enumerations is a helpful addition to the standard set of data types from JavaScript. In the enum, as languages like C#, an enum is a way of giving more friendly names to sets of numerical values. It's basically just a way of storing set values and just transferring them into translating them into numbers. Say we define X as a colors and colors blue, and we'll just return 0. And that way, it just simply stores 0 instead of the string blue or however. Also, a handy feature enums is the reverse lookup, where we can call the index of the enum and get the string back. By default, enums are numbered starting at 0, but you can change that like so and start at 1 or wherever you want. You can even number them however you want. You could also have them as strings, but unfortunately, the reverse lookup does not work when you do that. All right, null and defined. I'm not going to go over these too much. Mostly there can be a subset of other types, but you can type something as null. If it's always going to be null or it's always going to be undefined, you can just type it that way. Unknown type. The unknown type is for variables we do not know the type of, perhaps some user input, or we may want to accept all types for some reason. It is a type-safe way of telling the compiler the variable could be anything. With the unknown, we could narrow the type down after we get it with the type checks in an if or switch statements, moving forward with another function or assigning it a variable with the correct type. Never had any use case for the unknown type in my work, but I can imagine some use cases. Next, we have any. Any type is simply a way of turning off type checking. Generally, it is recommended to avoid using this type because the main advantage of using TypeScript is the type checking. Use cases or for any can be working with outside third-party JavaScript libraries that would take an inappropriate amount of effort to declare types. But for most third-party libraries, generally the most commonly used ones anyway, type of declarations are included or can be found separately and added to your packages. Next, we have never, which is one of those I was talking about. They'll really only be used for return type. Never types. For instance, never is the return type for a function that always throws an exception or error, or perhaps an infinite loop that just never returns anything. Next up, we have void. Void is just a return type for something that doesn't return anything, like calling another function or console log. Biggest use case for me is a set state function. Just something that's basically calling another function to set your state so it doesn't return anything, which would be void. All right, and like I said before, there was a better way of denoting your objects, and those are interfaces. To show an example, let us say we have a function like above that takes the object with the key message that is a string. Instead of typing it as function argument, we can create an interface for it, which is my object, which contains the key message that is a string, and use that as the type in the function instead. We can also interface to type multiple keys, and perhaps some objects may have keys that do not objects of their types. In that case, we can use the question mark to denote an optional property. So if the question mark is there, it doesn't have to be included when you say it's that type. And let's get into unions. Unions are for when a variable, argument, or something that may be more than one type. In these cases, we will be tempted to use any or unknown and do a type check. Instead, we can use a union to denote something maybe of multiple types. It's basically just a way of saying it can be a string or a number, and then we can do a type check in there and return however we want to do it. Like, so we have a type check for a number or string. If it's a number, we want to stringify it. We can also use the generic syntax to use unions inside of that to unknown an array that can be string or number. And, right. And next we have literal types, which now we know about unions. We do literal types. Literal types can also be numerical literal, string literal, any combination of basic types, such as Boolean or Null, maybe an option. So I don't think Null is a subset of or subtype of Boolean, so we could say that. And it can also be use union to be a subset of other literal types. Next, we have intersections. Like union is for or, intersections are and. We have an interface with the width and height, and we have a third dimension, which would be the depth. We can use an intersection to combine the two and call it a box. And then we have our area, and our third dimension would be an object that would be width, height, and depth. You can also use the extend keywords on interfaces to add more options. So box now extends area. We're just adding depth to width and number. This is another way of doing it too, outside of intersections. Type assertion, all right, is a way of, say we have an unknown variable. Something you'll end up in a situation where you know more about the value than TypeScript does. Usually this will happen when you know the type of some entity could be more specific than its current type. Type assertion is a way to tell the compiler, trust me, I know what I'm doing. Type assertion is like a typecast in other languages, but it performs no special checking or reconstructing of data. It has no runtime impact and is used purely by the compiler. TypeScript assumes that you, the programmer, have performed any special checks that you need. Type assertion has two forms. First, we have the is syntax, where we just say the value as a string, and then we can use it as a string and pull the length, and then that would be a number. Or we can do the, I guess, generic or angle bracket syntax. A note though on the angle bracket syntax, the two syntaxes are equivalent, but if you're using TypeScript with JSX, such as React or TSX in that case, only the as style assertions are allowed. All right, before we get into any live coding, we'll go over classes. Here we have a simple JavaScript class for a person. Takes a name and assigns it to the property name. And we have a method that takes a greeting and returns that greeting and the name in the form of a string. Now we can instantiate a new instance of the class and assign it to the me variable. Once instantiated, we can access the property value of name, assign it to a variable. We can also call the method giving it the argument hello, which will return hello, Justin. And here we have the same class in TypeScript. Not much difference. We're just noting our types, basically building an interface inside of it. so it knows what to expect and what this name is supposed to be. And the same with our greet, we are giving it a argument, noting the argument type and the return type. Now, just like before, we can instantiate it, assign it to a variable, and call the method. We can also do optional properties like before, where we like interfaces where you may not have that every time. You can also have default values for those optional properties. And now we'll get more into the generics. Major part of software engineering is building components that are reusable, and generics are a very useful way for writing reusable code. Here we have a function with the type checking turned off using any type. Instead, with generic syntax, we can use, instead of using any type, we can use a type variable, which would be t here. Now we can call that function, giving it a type. And now that function knows that type. We can also use generic syntax to make reusable interfaces, reusable classes. All right, and now my favorite part, some live coding. I just made a really simple React app here using the Swappy API. As you can see, we'll go to our index here, which you can see it's not really any different than JavaScript API. There's nothing special we have to do here. Come to the app where I added some stuff. TypeScript, you can see a little more differences here, like in the use state, I'm typing it here. I made a character model out of a class. So I know giving it all these and then assigning them. And when you're assigning the constructor, you can do things to it like the API gives me a string, and here I convert it to a number, have its built-in methods that I can use and call other functions and stuff. Basically, you see like some packages that include types, or like Axios has the types built in where you can just pull the type here so you can use it to assign it to a variable, like here where I'm calling the Swappy API just to get the people. And then if I get something back, I reassign it to the character model, feeding the proper inputs and then setting the data. And nothing crazy here either, just return type. Here I'm using a map where I have to type the map, where X is the character and I being the index is a number. And let's say with TypeScript, I have this character component built, which has an interface which knows it takes a character. I could add more properties here, and then here for the props, I'm using the props, the interface as the type. Back to the app. Say with TypeScript is really handy. Say I don't have that character here. I don't know what properties I want. So you can see here where it'll come up with a list of what I can type in. But right now it's just character. If I added other options in there, they'll show up there. So it's really, TypeScript's really helpful that way. And if I try and put something that doesn't belong there, it will give you a nice warning. Here it's expecting character to be something. So right now it just thinks it's a Boolean. So if I try and put in a string here, it's going to say string is not allowed. It's expecting a character, not a string. So, it's nothing crazy there. Any questions?
Again, feel free to throw questions in the chat or use the hand raise if you want to save me the embarrassment of mispronouncing the apps that you're asking about.
Thank you very much for that overview.
David, did you have a question?
No, I was just thanking you for the overview. It was very nice.
Okay, cool, thank you. Well, that's pretty much it.
I'm seeing a question in the chat, though maybe we can peek your test file there real quick.
Yeah. I didn't mess with it. It's just what came with it.
Gotcha. The other thing I saw mentioned earlier about Bill was the unknown type, which is not one I think I've seen before. I've usually seen any type as the escape hatch.
Unknown is basically the type safe way substitute of any. Unknown means it has a type, you just don't know what it is. So you can take it and it doesn't type check, but then it has to be assigned later. It's pretty much not the opposite of any, but it doesn't turn off type checking. So more into it. I really don't think it's commonly used. It's basically for if you're pulling something in that you don't know what the type is until you get it. So you can get the variable, then see what it is, and then type it.
Yeah, the example I saw was something that was going on at TypeScript. You know, their documents and stuff, and they're using it to swap a tuple. And so I think that's why they used the any, was because basically they were swapping it. They were assigning it to a string and a number, and then they were swapping it back the other way. So if you did that with an unknown, once the unknown's been assigned, you're kind of screwed. You couldn't swap it back again, I guess. So the only thing I could think of was maybe sorting like a tuple array, maybe something like that.
Well, then you wouldn't type it as a tuple. Colin says any is evil, which is kind of true. John's asking if any set the type, then it cannot be set to a different type later. No, I don't think that's true, because I think when you type it to any, you're just saying it can be any type. You can, if you figure out something that is a certain type from that any array or any object, then you can set it to another variable that is typed if it's the right type. The recommended use cases for any is basically, if you know what type it is, then use that type. Don't use any. Any is, say you're importing a outside library and you don't know what everything is, or it's going to take you a really long time to go through and type it. You can use any to turn off type checking on that outside library. Because like I said, all the common JavaScript packages that you use, like React or Axios, React Router, Express for Node, I'm pretty sure all those have the types included. Some less common use packages, you can usually find the package on npm. You just type at types / whatever the package name is, and if it exists, you can find it. And if it's already included in there, it'll probably tell you that it's already included. So if you're looking for it that way, but that's pretty much the only use case for any that I know of, but it's not recommended use because it pretty much turns off what you're using TypeScript to do. If you're using on a project and you're using any for a lot of stuff, you should probably just be using plain JavaScript then. Anybody else?
All right. Thanks, Justin. We can do another virtual round of applause for Justin. Thank you so much for presenting on TypeScript.